Welcome to today's deep dive. I want you to start by just imagining something for a second.
Okay.
Picture your computer screen right now. Imagine an AI that doesn't just sit there waiting for you to type a prompt into a little chat window.
Right.
Imagine one that can actually take over your mouse, use your keyboard, navigate your incredibly messy desktop, and knock out your most tedious admin work while you just sit back and watch the cursor move.
It's a pretty wild thought.
It is. Or how about an AI that writes the code for a brand new video game and then literally plays the game itself to test if the buttons actually work?
You know, it sounds like science fiction or maybe one of those heavily edited tech demos from a few years ago.
Yeah, exactly.
But that is exactly the threshold we are crossing today.
Because today is March 5, 2026, and OpenAI just dropped GPT-5.4 along with its heavy-hitting sibling, GPT-5.4 Pro.
Huge day.
Yeah, and we've got our hands on the official release announcement, the raw technical evaluations, and a whole stack of benchmark data.
There is a lot to get through.
There is. And our mission today is simple. We're going to cut through all the developer jargon, the benchmark acronyms, the dense technical specs, and uncover exactly what this means for you.
Exactly.
Whether you are a software engineer, a professional trying to buy back some hours in your week, or just someone fascinated by the bleeding edge of technology, this release completely changes the landscape of how we interact with computers.
It really does.
Okay, let's unpack this.
To set the stage properly here, we have to look at how OpenAI is framing GPT 5.4.
Right.
They are positioning this as their most capable and efficient frontier model, specifically designed for professional work.
A frontier model.
Yes. What we're seeing in these documents is the merging of three distinct evolutionary tracks in artificial intelligence.
Okay, what are those?
Advanced reasoning, elite-level coding, and what they call agentic workflows.
Agentic workflows.
Right. This is a unified system built to actually operate within software environments rather than just generating text about them.
I really appreciate how the release notes focus heavily on the phrase knowledge work, because we're not just asking the AI to write a cute poem about a dog in the style of Shakespeare anymore.
No, definitely not.
We are asking it to build complex financial spreadsheets, design corporate presentations, read dense 100-page documents.
Yeah, it's a completely different league.
It feels like a massive shift from interacting with a really smart chatbot to suddenly having an actual digital colleague sitting at the desk next to you.
And the underlying data supports that shift quite dramatically.
Does it?
Oh, absolutely. Let's look at the leap in performance. There is a rigorous evaluation called the GDP-Val benchmark.
GDP-Val?
Yes. It spans 44 different occupations across the top 9 U.S. industries. And it asks the AI to produce well-specified, real-world work products.
Like what kind of products?
We are talking about tasks like drafting sales presentations, creating urgent care schedules for a hospital, or building accounting models.
Wow.
And on this benchmark, GPT 5.4 matches or exceeds the performance of human industry professionals 83% of the time.
Wait, 83%. So if it's operating at the level of a human professional more than 8 out of 10 times,
Yeah.
what happens to the junior employees who usually do that foundational grunt work?
That is the pivotal question this release forces us to ask. For context, the previous generation, GPT 5.2, was sitting at around 70% on that same test.
Okay, so a 13% jump.
Right. This isn't just an incremental update. It is a massive generational leap in reliable professional-grade output. It effectively turns the human operator from a creator of first drafts into an editor and a strategist.
I want to make that real for you listening, because looking at the specific real-world applications in these sources is just mind-blowing. Let's take spreadsheets, for example.
Sure.
There is an internal benchmark designed to test the exact kinds of grueling tasks a junior investment banking analyst would do at 2 in the morning.
The really painful stuff.
Yes, exactly. GPT 5.4 is scoring over 87% on those tasks, which is a huge jump from the last model.
It's math.
It's practically doing the heavy lifting of a first-year Wall Street analyst, and it's not just crunching numbers in a grid either.
Right.
On generating presentations, human raters preferred 5.4 over the older models for roughly 68% of the time. They specifically noted that it has better aesthetics, more visual variety, and utilizes image generation much more effectively to tell a story.
But of course, none of that visual polish or rapid data crunching matters if the underlying information is fundamentally wrong.
Yeah, that's the catch, isn't it?
Exactly. A beautiful presentation based on a hallucinated statistic is worse than useless in a professional setting.
It could get you fired.
Exactly. And that brings us to a critical part of these evaluations, which is accuracy. With this release, we are seeing a vital drop in those AI hallucinations.
That's good news.
On complex prompts where users historically flagged factual errors, GPT 5.4's individual claims are roughly a third less likely to be false.
A third.
Right. And even better, when you look at the entirety of its output, full responses are nearly 20% less likely to contain any errors at all compared to the 5.2 model.
Which is basically the baseline requirement if you're going to trust this thing with actual deliverables that go to a client or a boss.
Precisely. There is a telling quote in the release from Nico Grupin.
Who is that?
He's the head of applied research at Harvey. They build AI tools specifically for legal professionals.
Okay.
He notes that GPT 5.4 scored a 91% on their Big Law Bench evaluation.
91%.
Yeah, and he points out that structuring complex transactional legal analysis requires maintaining accuracy across incredibly lengthy, dense contracts.
Oh, you can't just skim those.
No, you need a persistent level of granular detail. If an AI forgets a crucial clause on page 40 while analyzing page 80,
The whole thing falls apart.
the entire legal argument falls apart. Previous models really struggled to hold that deep context without making a critical error, but 5.4 is setting a completely new bar for document-heavy, high-stakes legal work.
Here's where it gets really interesting, though.
Oh, yeah.
Because being smart and accurate is one thing, but being able to take action is another entirely. This release introduces what the technical docs call native computer use capabilities.
This is arguably the most monumental shift in the entire update.
Really?
Absolutely. GPT 5.4 can now act directly as a human user would on a device.
What does that look like in practice?
It can write scripts to operate computers using automation frameworks, or, and this is the part that changes everything, it can literally read a screenshot of a user interface and issue direct mouse and keyboard commands.
Just from a screenshot?
Yes. It uses what they call coordinate-based clicking to navigate any software, moving the cursor to specific X and Y coordinates on your screen, just like you or I would.
Okay, I have to challenge the numbers I'm seeing in the sources here,
Mm.
because the benchmarks on this are wild.
They are surprising.
There's a test called OSWorld Verified, which measures a model's ability to navigate a desktop environment using just screenshots and mouse actions.
Right.
GPT 5.4 achieved a 75% success rate. But the report says the human performance baseline for this exact same test is roughly 72.4%.
Yes.
I find that really hard to believe.
Huh.
How can an AI be better at using a mouse and a desktop than someone who has been using a computer for 20 years? What is that human baseline actually measuring? Did they just find people who don't know how to use a computer?
It's a highly counterintuitive statistic, I agree, but it makes sense when you break down how the test works.
Okay, break it down for me.
The benchmark requires completing complex multi-step tasks across different operating systems.
Like what?
Just very tedious administrative chains of action. When human beings do this, we get distracted. We misread the instructions, we accidentally click the wrong drop-down menu, get frustrated, abandon the task, or we simply don't know where a specific system setting is buried.
Okay, that's fair. I've definitely rage quit a bad website before.
Exactly. The 72.4% human baseline accounts for all that natural human error and fatigue. The AI, on the other hand, is ruthlessly task-focused.
It doesn't get bored.
It doesn't get tired. It processes the entire visual layout instantly, and it executes the precise sequence of clicks required. It is officially statistically better at reliably executing desktop navigation tasks than the average human user.
That is wild. I was watching the video demo they included in the sources, and it really brings this to life.
It's impressive to watch.
It's a real-time unsped video showing the AI looking at a standard browser. You literally watch the cursor move. It interprets the screen, clicks on the right text fields, drafts a cohesive email, hits send, and then jumps over to a calendar app to schedule a follow-up event.
All autonomously.
Seamlessly. There's a quote from Dodd Frazier, the CEO of a company called Mainstay, that gave a perfect, painful, real-world example of why this matters.
Oh, the tax portals.
Yes. They tested this AI across 30,000 different homeowner association and property tax portals. And if you've ever had to pay a local tax bill online, those websites are usually a nightmare of terrible, outdated UI design.
They are notoriously difficult to navigate even for humans.
Yeah, exactly. But GPT 5.4 hit a 95% first-try success rate navigating these archaic portals. It figured out where to click, and it did it 3 times faster than previous models while using drastically less computing power to figure it out.
And that's tied directly to its vision processing upgrades.
Oh, right.
GPT 5.4 has an incredible original image input detail level. It supports up to 10.24 million pixels.
10 million pixels. That's incredibly sharp.
Right. This is why its document parsing is so good. The Omnidoc bench error rate is down to 0.109.
Yeah.
Its spatial awareness on a screen is just incredibly precise.
But that brings up a massive question.
Yeah.
That level of autonomy is incredible, but also slightly terrifying.
In what way?
Well, if this AI can navigate any operating system autonomously, read the screen, click around, what stops it from doing something malicious? If it can pay a tax bill, it can presumably navigate to a secure server and start deleting files.
That is the exact concern security researchers have, and OpenAI addresses it directly in their preparedness framework.
What do they say?
They are officially treating GPT 5.4 as having high cyber capability.
High cyber capability.
Yes. Because of that, they are deploying it with specific expanded protections. For instance, they use asynchronous blocking for higher risk requests, particularly on what are called zero data retention surfaces.
Okay, let's translate that. What is a zero data retention surface?
OpenAI is putting up guardrails, especially for enterprise and government users who need absolute privacy. Zero data retention, or ZDR, means the AI can do the work within the company's secure environment, but it does not learn from, store, or transmit any of that private data back to OpenAI's servers.
Okay, so the data stays locked down.
Exactly. The safety mechanisms have to be robust enough to monitor the AI's actions locally without violating that strict data privacy.
But how do they monitor it if it's operating autonomously?
This is where we find a fascinating technical nuance in their safety research. They evaluated GPT 5.4 Thinking on a metric called chain of thought controllability.
Chain of thought controllability.
Essentially, they wanted to see if the model could be instructed to deliberately hide or obfuscate its internal reasoning process to evade human monitoring.
Oh, like if it could lie about what it was planning to do.
Yeah.
And what did the data show?
It showed that its chain of thought controllability is actually very low.
Which sounds incredibly bad at first glance. You would want high controllability over an AI, wouldn't you?
You would assume so. But what's fascinating here is that in this specific context, a low score is actually a massive victory for safety.
Why is that?
It means the model fundamentally lacks the ability to deliberately hide its reasoning process. It cannot operate in the shadows or keep secrets from the user.
So it has to show its work.
Exactly. Human monitors can clearly see exactly how and why it is making decisions step by step. Because the AI cannot mask its internal thought process, it prevents evasive, malicious misbehavior. Transparency is effectively baked into the architecture.
I love that. Transparency by design. It's like having a coworker who literally cannot stop narrating their inner monologue while they work.
That's a great way to put it.
So we've established it can safely navigate an operating system and do a lawyer's paperwork. But let's shift gears and talk about the people who actually build those operating systems.
Yeah.
Because this model also fully incorporates the capabilities of GPT 5.3 Codex.
Right. It's bringing a massive upgrade for developers.
Yeah.
It merges top-tier reasoning with industry-leading coding abilities. And a major focus for developers is maintaining a state of flow.
That flow state is everything.
It really is. They have introduced a new mode in Codex specifically for GPT 5.4, simply called /fast.
/fast.
Yes. When a developer toggles this on, it delivers a 1.5 times faster token velocity.
Let's clarify token velocity for a second for everyone.
Yeah.
Think of tokens like syllables or fragments of words. Velocity is just how incredibly fast the AI is typing those out onto the screen.
Correct. The underlying intelligence and problem-solving capability remain exactly the same, but the system generates the code 50% faster.
Which is huge if you're waiting on it.
Exactly. For a developer who is actively iterating on a complex problem and debugging line by line, eliminating that friction of waiting for the AI to finish typing is crucial. It keeps the human in their creative flow state.
But speaking of coding, the demo that absolutely blew my mind was the Playwright Interactive Showcase.
That was something else.
And just a quick definition for you listening, Playwright is essentially a framework that developers usually use to automate testing in web browsers.
Right.
So in the demo, the prompt given to the AI was to create an interactive isometric theme park simulation game that runs right in the browser.
Like those classic roller coaster games from the late 90s.
Yes, exactly like those. I fully expected it to just spit out a giant block of code, hand it to the user, and basically say, here you go, hope it compiles.
That's how it used to work.
Right. But it didn't do that. It actually opened a browser and started playing its own game. How is it doing that?
This ties directly back to its agentic capabilities. The AI didn't just write the code, it used Playwright to interact with the output.
So it wrote it and then tested it.
Yes. It would write the initial code for the theme park, open the browser, and then use its vision capabilities to look at the game it just built.
That's crazy.
It placed virtual walking paths, it built a few rides, and then it actively checked the guest pathfinding to make sure the little simulated people could actually navigate the park.
It was watching them walk around.
Exactly. It monitored the guest happiness metrics. It verified that the user interface correctly updated when money was spent on a new attraction. It did all of this autonomously over several rounds of play.
Just spotting bugs and correcting its own code along the way.
Yes. If we connect this to the bigger picture, this represents a fundamental shift in software development. This is no longer just code generation.
What is it then?
This is autonomous software engineering and quality assurance wrapped into a single loop. The AI is acting as the lead developer, the QA tester finding the bugs, and the end user experiencing the product all simultaneously.
All at the exact same time.
Right. It evaluates both the functional mechanics and the aesthetic results of its own code in real time.
It's unbelievable. Now moving on to another feature that solves a major problem you might not even realize existed, and that's giving an AI too many tools.
Yes, the tool problem.
Historically, if you built an AI agent and gave it a massive toolbox of external connections, what developers call an API, the behind-the-scenes bridge that lets different software talk to each other, it would completely clog up the model's brain.
Yes, the context window would get overwhelmed. The previous method required loading all the tool definitions upfront into the prompt.
Before you even asked it anything.
Exactly. For enterprise systems with hundreds of internal tools, that meant feeding the model tens of thousands of tokens of instructions before you even asked it a single question.
Which sounds inefficient.
It was incredibly slow and cost an absolute fortune in computing power.
So the sources show they solved this with a new API feature called Tool Search. And the best way to understand this is to think of it like a mechanic. In the past, if you hired an AI mechanic to fix your car, it had to physically carry its entire massive 5,000-pound toolbox to every single job, which slowed it down and cost a fortune in transportation.
Right.
With Tool Search, the AI just carries a little pocket index card with a list of tools. It assesses the engine, realizes it needs a very specific metric wrench, and instantly teleports just that one wrench into its hand, uses it, and puts it back.
That is a perfect analogy. Instead of the whole encyclopedia, it searches for the full definition of a tool only at the exact moment it needs it.
Makes so much more sense.
They evaluated this using the MCP Atlas benchmark, where they gave the model access to 36 different servers packed with tools.
Yeah, how to do?
By using tool search instead of the old method, it reduced total token usage by a massive 47%.
Almost half.
Right, while maintaining the exact same level of accuracy. It makes complex multi-tool agents vastly cheaper and infinitely faster to run.
Speaking of searching, we have to touch on its web search capabilities. GPT-5.4 Pro hits an 89.3% accuracy rate on the BrowseConf benchmark.
Which is incredibly high.
Yeah, and what stands out in the sources is how relentless it is. It doesn't just do one Google search and give up. It is willing to dig through multiple rounds of complex searches to find highly specific needle-in-a-haystack information across the web, and then synthesize it into a coherent answer.
And while it's doing all of this deep thinking and persistent searching, OpenAI has vastly improved the human user's ability to steer the model.
The steerability feature is brilliant. Let's walk through a highly relatable scenario for anyone using ChatGPT.
Okay.
They've added a feature called preambles for the GPT-5.4 Thinking model.
Right.
Say you ask it to analyze a 50-page quarterly earnings report and summarize the key risks. In the past, it would just start thinking and then spit out a massive final answer.
And if it was wrong, you had to start over.
Exactly. If it focused on the wrong thing, you had to start over. Now it explicitly outlines its plan first in a preamble. And here's the kicker. You can actually jump in mid-response and adjust its course.
Which is an enormous time saver for complex workflows.
Huge. Imagine it starts writing its plan, and halfway through you realize it's focusing heavily on market trends instead of supply chain risks.
You don't have to wait for it to finish.
Right. Instead of waiting for it to finish, reading a completely useless output, and wasting your prompt limits, you just tap the brakes. You correct its trajectory mid-thought, say actually focus on the supply chain, and it seamlessly adjusts its internal reasoning on the fly.
It prevents so much frustration.
It really does.
This raises an important question about how we interact with these systems. It highlights the collaborative nature of this new model. It is designed for dynamic back-and-forth iteration, not just crossing your fingers and hoping a one-shot prompt works perfectly.
Okay, let's run through the practical logistics, because I know people listening are wondering how they can actually get their hands on this, how much it costs, and what happens to the older models they might have built their current workflows on.
Sure. The rollout is happening gradually starting today, March 5, 2026. GPT-5.4 is actively replacing GPT-5.2 Thinking for Plus, Team, and Pro users in the ChatGPT interface.
Okay.
It is also going live in Codex and through the developer API.
And for those enterprise users who have complex, delicate workflows heavily dependent on the older model, don't panic. GPT 5.2 Thinking isn't vanishing into thin air overnight.
No, they have a transition period.
It's going to stick around as a legacy model for 3 months to give you time to transition. But mark your calendars, it will be fully retired and shut down on June 5, 2026.
Good to know.
What does the pricing structure look like for the developers tuning in?
In the API, the raw per token cost is definitively higher.
How much higher?
GPT 5.4 is priced at $2.50 per million input tokens, compared to 5.2's $1.75.
Okay, so a bump in price.
Yes. However, there is a crucial economic caveat here that developers need to understand. Because GPT 5.4 is OpenAI's most token-efficient reasoning model to date, especially when you factor in features like the tool search we discussed, it uses significantly fewer tokens to solve the exact same problems.
Oh, I see.
So while the per-token rate was higher on paper, the overall cost for actually completing a complex task might drop, because it requires far less back-and-forth prompting and drastically less bloated context windows.
That makes total economic sense. You're paying a slightly higher hourly rate for a contractor who finishes the job in half the time.
Exactly.
Oh, and for the heavy-duty software engineers, Codex now features an experimental 1 million token context window specifically for GPT 5.4.
1 million tokens.
Just be aware of the fine print. Any requests that exceed the standard 272K window will cost double the normal usage rate.
Still, having 1 million tokens of context while an agent autonomously engineers, reads documentation, and playtests software is an unprecedented capability for software development.
So what does this all mean for you? To summarize everything we've unpacked today, GPT 5.4 is not just an incremental upgrade to a text box.
Not at all.
It is the realization of the autonomous digital coworker.
Yeah.
With native desktop navigation that statistically beats the human baseline, real-time playtesting capabilities, massive drops in factual hallucinations, and the ability to course-correct its thinking mid-stride.
It really is a paradigm shift.
It is designed from the ground up to take over the operational friction of knowledge work. Which brings me to my question for you, the listener.
Yes.
Think about your day-to-day work routine. What is that one repetitive, multi-step, soul-crushing computer task that you absolutely dread doing every week? Because as of today, you might actually be able to just hand it off and watch the cursor move on its own.
It's a compelling thought, and it invites a reevaluation of our daily routines. But I want to leave you with one more profound concept to mull over.
Let's hear it.
We spent a lot of time discussing how GPT 5.4 achieved that 75% success rate on the OS World benchmark, statistically beating the human baseline at navigating a desktop environment using a mouse and keyboard.
Right.
Think about the long-term implications of that specific data point. For 40 years, operating systems, software interfaces, and websites have been painstakingly designed for the human eye and the human hand.
Because we were the only ones using them.
Precisely. But if AI agents become the primary entities operating software, navigating those terrible property tax portals and clicking through complex web forms, what does this mean for the future of user interfaces?
Wow.
If the human is no longer the one doing the clicking, will the software of tomorrow even need a visual screen? Or will the operating systems of the future be completely invisible, redesigned from the ground up to cater purely to an AI's data processing, leaving the human screen as a relic of the past?
A completely invisible digital world where the computer just talks to the computer. That is a wild paradigm shift to think about. Thanks for joining us on this deep dive, and we will catch you next time.